In this presentation, I'll be talking about two very common non-parametric tests of hypothesis procedures. Before I start talking about these procedures, I would like to discuss why do we need to know about non-parametric tests. The most important reason is that we do not need to have the normality assumption. If you recall, whenever we were talking about one population or two population, test of hypothesis or inferential statistic, we were always emphasizing on the fact that we need to have the normality assumption for the population that we take the samples from. But it happens a lot that in practice we do not have the normality assumption, or simply the normality assumption is not valid. So what should we do in these cases? As a result, we need to know about the non-parametric tests. The very first procedure that I want to talk about today is the sign test. Sign test is a very good and very common technique when you want to test the median or average of a continuous distribution when you do not have the normality assumption. For example, I want to test and see if the average of the population is equal to 100 or not. Or I want to know if average length is greater than 10 millimeters or not. And in these cases, I do not have the assumption of the normality for the population that I take my samples from. So in these cases, if I want to run the sign test, I need to form the differences between each individual observation and hypothesized value. And afterwards, all I care is about the sign of that difference. So let's look at one example. In this example, we have collected 20 samples. So as you can read over here, the shear strength of the bond between the two propellant types is an important characteristic. The results of testing 20 random selected motors are shown here. I want to test the hypothesis that the median shear strength is 2000 psi when alpha is equal to 5%. Again, I'm emphasizing on the fact that I do not have the assumption of normality, and that is why I have to use the non-parametric test. And for now, I'm just focusing on the sign test. We said in this test, for this technique, all I care is the differences between individual observations and the hypothesized value. So do you agree that over here, the test that I'm running is H0 is saying that mu is equal to 2000. It's a two-sided test versus the case that mu is not equal to 2000. So as you can see, the hypothesized value is 2000. So what I need to do for this technique is to find the difference between each individual observation and 2000. Xi minus 2000. Be careful about the order in the difference between individual observation and hypothesized value. X minus 2000. So in this column, I have calculated the differences, but I really do not care about the magnitude. All I care for in the sign test technique, all I care is only about the sign of that difference. Some of these signs are positive, or some of these differences are negative. All I care is about the number of positive differences and number of negative differences. For example, you can see that among these 20 differences, 1, 2, 3, 4, 5, and 6 differences are negative, and of course the remaining 14 differences are positive. Now, how can I use these numbers of positive and negative differences? So as you can see over here, if I have a two-sided test like the example that we are solving, I need to calculate R, which is the minimum of number of positive differences and negative differences. If that value is less than a threshold, I will reject the null hypothesis. Otherwise, I will fail to reject the null hypothesis. So the question that you might have, okay, how can I find this critical value over here? The critical value for the sign test is coming from a specific table that you should be able to see that in the appendix section of your textbook. All the way at the end of your textbook, you will see the non-parametric test sign test table. Also, I have provided that table through the list of the tables that you see on your blackboard. So in this example that we just saw, we had a two-sided test. I want to see if mu is equal to 2000 versus h1 versus the case that h null mu is equal to 2000, h1 mu is not equal to 2000, mu is equal to 2000, mu is not equal to 2000. So for this test, in the previous table, I just counted for you, and we knew that I had 6 negative differences and I had 14 positive differences. And considering the fact that I have a two-sided test, I need to calculate R, which is the minimum of number of positive and negative differences. Minimum of how many positive differences I had? 14. How many negative differences I had? 16. So if R is equal to minimum of 14 and 16, it will be equal to 6. Now I have to compare it with a threshold. The question is that what is the threshold for this test? So let's go to the next slide where I have attached the table. So in this example, I had 20 observations. So I am in this row. And I'm talking about a two-sided test. What was the value of alpha? Alpha was equal to 5%. So I have to come down in this column, and in the intersection of 20 and this column is the critical threshold of 5. So I need to compare 6, that minimum, with that threshold, which was equal to 5. We said if 6 is less than threshold, we will reject it. But in this case, we will see 6 obviously is greater than 5. So our conclusion for this example is that I will fail to reject the null hypothesis. And I can say that I cannot reject the null hypothesis that the median strength is 2000 psi. So that was one example for a two-sided test. But the question is that what should I do if I have a one-sided test? Depending on type of test that we have, our rejection criteria might differ. And I have marked it with red and green in this slide. If I have a one-sided test, upper-sided test with H1 looking like this, I will reject my null hypothesis if the number of negative differences is less than threshold. And if I have a lower-sided test, I will reject my H null if the number of positive differences is less than threshold. So in other words, if I want to summarize it, I can say that if my H1 is two-sided, mu is not equal to mu naught, I have to calculate, I will reject my H null if minimum of number of positive and negative differences is less than R star. If I have a one-sided test, and let's say I have upper-sided test, for example, is greater than mu naught, I will reject H null if R minus is less than the threshold. And if I have an upper-sided test looking like this, I will be rejecting my H null if R plus is less than the threshold. And this threshold, depending on type of test that we have, is coming from sign test table that you have in the appendix of your textbook, or you can find it on the table folder on the Blackboard. Under some condition, we might be able to use the normal estimation for sign test. In cases that your n is at least equal to 10, it means that your sample size is at least 10, is greater than equal 10, you should be able to use the normal estimation. In these cases, we will use r plus, which is the number of positive differences, minus 0.5 times number of observations or number of samples divided by 0.5 square root of n. In this case, you will have a z-test statistic, and the good news is that since you have z-test statistic, your acceptance rejection region will follow regular normal distribution cases that you have had in previous chapter, like one-sided or two-sided. You have to compare it with z alpha or z alpha over 2 and conclude. For the problem that we solve, I'm going to solve it using normal estimation. So for this problem, I had a two-sided test and I wanted to use the normal estimation. The number of positive differences, if you remember, it was 14, where I had 20 observations. So minus 0.5 times 20 divided by 0.5 square root of 20. So in this case, you will see that the test statistic will be 1.78. Regarding the fact that I have a two-sided test, I can say my acceptance rejection region will look like this. Anything greater than 196 or less than 196 will lead to the rejection of H null. But I can see that the value for my test statistic is somewhere around here, is 1.78. As a result, my conclusion is to fail to reject H null. In other words, I would say we cannot reject the null hypothesis that the median shear strength is 2000 psi. Again, have in mind that you can use normal estimation for sign test when your n is at least equal to 10. Otherwise, you can use the sign test tables that you have in the table 8 in the appendix section of your textbook, which should be page 760 of your textbook.